all, welcome to EC Electronics. Today's class we are going to see some questions from the number system conversions of digital electronics. This will be useful for your examinations if you are preparing for ISRO technical assistant or scientist post. Okay, so let us see what is the first question. Convert 1e2 to the base 16 to decimal. So 1e2 to the base 16 means it is represented in which representation in the hexadecimal number format. That means to the base of 16. We need to convert it to decimal, that is to the base 10. Okay, so how to convert this number in hexa to decimal very fast? I'll show you. The number is 1e2, right? So the number e represents 14. We know that E represents 14 and F represents 15, right? So, we can write it as 1, 14 and 2. And just replace the E with the 14. Now, it is to the base of 16, right? So, this has a position value of 16 raised to 0. This 16 raised to 1. Here it is 16 raised to 2. So, just multiply these numbers and add. That is 16 square into 1, 16 square into 1 plus 16 raised to 1 into 14 plus 16 raised to 0 into 2. So, 16 square is 256 plus 14 into 16. 16 raised to 1 means 16. 16 into 14 is 224. 224 plus 16 raised to 0 is 1. So, 2. Now, add these numbers. 6 plus 4 is 10. 10 plus 2 is 12. So, 12, 5, 8, 4, 82 is your answer. Okay, so the correct answer for this question is 482. This is to the base of 10. That is, it is a decimal number representation. Okay, so the correct answer is 482. And this is how you can convert a number in hexa, that is in 16 base, to 10 base, that is to decimal. Okay, I hope it is clear. Now, let us do the next question. I'll make little space for this. Okay, next question is convert 24 to the base 8 to binary format. Now, to the base 8 means octal representation, right? So, octal representation we need to convert to binary, that is to the base of 2. Okay, so if you face such a question, don't waste time for converting it to decimal or to any other format. Just write the 3-bit binary representation of each of these numbers. That is, there are two numbers, 2 and 4. We need to convert that numbers to binary. Since this number is in octal, we know that in octal, each numbers, that is, we pair the numbers by 3. So, just convert this number, that is 2 and 4, to binary with 3-bit representation. So, how can you represent 2 in binary with 3-bit? That is 0, 1, 0. 2 will be 0, 1, 0 and 4 will be 1, 0, 0, right? So, 24 to the base 8 can be represented as 0, 1, 0 and 1, 0, 0 in binary. So, this is how you can convert a number in octal to binary very fast. Just convert each of the numbers to the binary representations with 3 bits. Okay. So, the correct answer will be 0, 1, 0, 1, 0, 0, which is your option. B is your correct answer. This is your answer, that is 0, 1, 0, 1, 0, 0 to the base of 2. Convert 0, 1, 0, 1, 1 point 1, 0, 1, 1 to the base 2 to decimal. Okay, so how to convert such a number which is having a point to decimal number format, that is to the base 10. I'll write it, I'll write the powers in 2 for each of these number positions. First, I'll write the numbers 0, 1, 0, 1, 1, point, 1, 0, 1, 1. So, this is your number. Okay, now I am going to write the position values for each of these numbers. So these numbers are having positive powers, that is before the decimal. After this decimal point, these numbers are having negative powers. Okay, so here it is 2 raised to 0, here it is 2 raised to 1, here it is 2 raised to 2, this is 2 raised to 3, and this is 2 raised to 4. Okay, after the decimal point, it is 2 raised to minus 1, 2 raised to minus 2, 2 raised to minus 3, and 2 raised to minus 4. Now, just cut out the values which is having a value of 0 above. So, you can remove this, this, and this. Now, first add these numbers and find what value is coming. So, it is a 2 raised to 3 into 1. That is 2 raised to 3 plus 2 raised to 1 into 1, 2 raised to 1 plus 2 raised to 0 into 1 means 1. So, it is a 2 raised to 3 means 8 plus 2 raised to 1 means 2 plus 1. So, 8 plus 2 plus 1 is 11. So, the value is 11. Now, 11 point, we have to find the rest of the values. Okay, so from the option, one thing is clear. Your option is not C and your option is not D. Because that is having value 10 points. We need 11 point something will be your answer. So, after this, what are the values? 2 raised to minus 1 into 1. That is 1 by 2 plus 2 raised to minus 3 means 1 by 8. So, 1 by 8 plus 2 raised to minus 4 means 1 by 16. Okay. So, what is the value of 1 by 2? It is 0.5. What is the value of 1 by 8? It is 0.125 plus 0.125 plus 1 by 16 means plus 0.0625. Okay. So, if you add it, what will you get? 6. 2 plus 6 is 8, 2, 5, right? Sorry, 7, 5. 0.6875, yeah. So, your option A is your correct answer. You will get 11.6875 to the base 10. Okay, so the correct answer will be 11.6875 or your option A will be your correct answer. Next question. Convert this number, that is 110110001010 to the base of 2. It is given in a binary format to octal. So, we have discussed a question of converting octal to the binary format. Now, we are going to convert a binary to octal. So, I have tried to include all the conversions in this video. So, please do watch this video till the end if you are preparing for any electronic based exam. Okay, so we are going to convert. I'll write the number here. 110, 110, 001, 010 to octal format. Okay, so start pairing the number by 3, 3 each. So 3, 3, 3, 3. Just take pair of 3, 3 numbers and write the corresponding value of these numbers. That is 010 means it is a 2. 0011 means it is a 1. 110 is a 6. 110 is again a 6. So the number will be 6612 to the base 8. So this is how you can convert a binary number to octal format. Okay, so the correct answer will be 6612 or your option B is your correct answer. Question is, convert 651.124 to the base 8, that is an octal representation, to hex. Okay, that is we need to convert the number in octal to hexadecimal format. The easiest way is to convert from an octal to hexa or from a hexa to octal. First convert it into binary format and then do the conversion. That is the easiest way. Okay, so 651.124, how to convert it to hexa, I will show you. First, write the binary representation with 3 bits. Okay, so how to write, we'll start from this side. How to write a 4 in binary with 3 bits? It is 1, 0, 0, right? Then 2 is 0, 1, 0. 1 is 0, 0, 1. Point. 1 is again 0, 0, 1. 5 is 1, 0, 1. 6 is 1, 1, 0. Right. This is how you can convert octal to binary with 3-bit representation of each number. Now, if you see this number representation, this is having a 0 here. Okay, so we'll remove this because it is in the after the point, that is not significant. Now try to pair these numbers as how many numbers we need? 4 numbers, because we know that in hexa the numbers are paired as 4. So we'll make a 4 number pairing. Okay, so starting from this side, I'll do the pairing. 1, 2, 3, 4. 1, 2, 3, 4. Here 1, 2, 3, 4. 1, 2, 3, 4. Okay, so while pairing, I have a 1 here. So in order to make a 4 number, I'll add 3 zeros. So this is a 16. Okay, so in order to make a pair of 4, I have added 3 zeros here to the last one left. Okay, now I'm going to write the corresponding numbers for these binary bits. Okay, so what is a 1, 0, 1, 0? It represents A. Then 0, 0, 1, 0 is 2. Then 1, 0, 0, 1 is 9. Again 1, 0, 1, 0 is A. Then 0, 0, 0, 1 is 1. So this is your hexa number corresponding to this octal number. Okay, so that is 1A9.2A to the base 16. This is your hexadecimal number for this octal number. Okay, so the easiest way to convert a hexadecimal number or an octal number to the other. That is, if you want to convert an octal number to a hexa number, first convert that octal number to the, if it is an octal number, make a 3-bit binary. That is, for each of these numbers, write the binary number with 3 bits. Then, after writing the number, if you have any insignificant values or zeros, just remove it and then make pairing of 4 numbers each or 4 bits each and write the corresponding values. Then you will get 1A9.2A to the base of 16. Okay, so the correct answer for this question is option A, which is 1A9.2A to the base of 16. And also, while pairing, you will start from this side. Okay, so while pairing, if any number is not having significant values, that is, if there is no 4 bits to pair, means add zeros. Okay, so this is how you can convert an octal number to hexa number. Okay, next question. Convert 214 to the base 8 to decimal. So here we need to convert the octal number to decimal format. So I'll write the octal number here. It is a 214 to the base of 8. Right. So we know that if it is an octal number, it is having of position values as power of 8. So this 4 is having a position value of 8 raised to 0. 1 is having a value of 8 raised to 1. Then 8 square. Right. Now multiply these values with the corresponding position values and add. That is 8 square into 2 plus 8 raised to 1 into 1 plus 8 raised to 0 into 4. Okay. So this is how you can convert a number in octal to decimal. So if you want to convert any number to decimal, means multiply with its corresponding powers. or position values. So 8 square is 64. 64 into 2 plus 8 plus 4. So 128 plus 12 is equal to 140 to the base of 10. Okay, so the correct answer will be option A, which is 140 to the base of 10 is your correct answer, or option A is your correct answer. Convert 0.345 to the base 10, that is a decimal number, to octal number. Okay, so how to convert a decimal number to octal number? So we just before we have done a number of octal conversion, we have done to decimal, that is we have multiplied with power of 8, right? That is 8 square, 8 raised to 0 into 8 raised to that is corresponding values plus, likewise we have multiplied with the 8 powers to convert a octal to binary, octal to decimal. Now we are going to convert a decimal to octal. So for that we need to, since this is a point number 0.345, we need to multiply this number with 8 till the value or till the quotient value is approximately close to 1. Okay, so 0.345 into 8 will get 2.76. Now from this take the quotient, take the integer value. So it is a 2.76, so take the integer value which is 2. Now take the decimal from this result obtained, that is this value we are going to take. 0.76 into 8 again. So what will be the value? Value after the point, that is 0.76. I am going to multiply it with 8 again. So I will get a 6.08 here. Okay. So again I am going to take the integer position from this result. So I will get a 6. Okay. Now take this again, 0.08 into 8 again. Okay. So it will be 0.64. So 0 is the integer position. So it is a 0. Okay. So likewise you have to perform the multiplication till this value, that the integer value will be closer to 1, or we will get a 0.9 something in the after the decimal position. Okay, so till that you have to perform the multiplication, and you have to take these integer values to get your octal representation. Okay, so we have performed 3 multiplications here and we have obtained the values as 2, 6 and 0. We have multiplications left, but if you see your answer, see here it is a 0.160. Our first number is 2, right? So this is not our answer. Next is 0.260. Yes, it is a 2, 6 and a 0 we are getting, right? So this is a decimal number, that means a point number. So 0.260. Till this we have obtained. We have the multiplications left, but we are not doing that multiplication. There is only one option corresponding to 0.60 or numbers close to that, because the next number is 0.1945, which is not. Also the last option is 0.240, which is not our option. So this is not our answer. This is also not our answer. Our answer will be option B, since for the 3 multiplications we have obtained values as 2, 6 and 0. So our result will be starting with 0.260 and likewise the result will be going to the base of 8. Okay. So if you are attempting such questions, don't do all the multiplications. Just do 2 or 3 multiplications and then see your options. Here if you see the options, only one option is close to this or exactly the value is same. See 0.260, here also 0.260. So you don't have to do more multiplications which will be time consuming. Okay, so the correct answer is option B, which will be 0.26050 to the base 8 is your octal number representation corresponding to this decimal number. So I am telling you it again that if you are attempting these type of questions in your competitive exam, don't skip this question. First of all, you have to do 2 or 3 multiplications, and I'm sure and I'm pretty sure that if such questions are being given, the numbers will be different by the positions, because since it is a lengthy process, you don't have to do all the multiplication. Just see the options and you will get the option within maximum 3 multiplications. Okay, so here it is 0.26050 and your answer will be your option B. Okay, I hope this is clear. Okay, so these are some questions which I have included in this video. So we have done conversions of octal number to hexa, decimal number to binary number. We have done lot of conversion problems. These problems are very much important in competitive exam related to electronics, because we know that the number system in digital electronics is given a good weightage of mark. So my request is that if you have watched this video till the end, now try to do all these problems. By watching the video once again, just note down the questions and try to do these problems and try to see whether you get the answer or not. Okay, and also if you want more videos on number systems and conversions, please do mention in the comment section. We'll be doing the videos more if you want these type of videos. Okay, so I hope this video was useful for your preparation. If yes, please do give it a thumbs up and also share this video with all your friends. And if you want more videos, please do subscribe to the channel. Thank you.